fifth graders, this week you are going back to division. However, now you're going to be dividing with decimals. So if you look at the three problems I have here on the page, all three problems have a decimal and a dividend, and they're being divided by a whole number. So that's the first lesson with traditional long division that you're going to do today. The steps of division are written down the side for you to refer to. We use the mnemonic, does McDonald's sell cheeseburgers rare or raw? That reminds us of the steps: divide, multiply, subtract, check, bring down, or remainder, or repeat. So let's go through the steps, and I'm going to do a little bit of practicing with you just to show you what you're going to do when you solve problems like this. I always like to begin with estimation. I think estimation is a good way to check your work as you're doing it to make sure you're doing it correctly. So we have 6 divided into 6 and 78 hundredths. Usually when I'm dividing with decimals, I ignore the decimal part and I just look at the whole number. So I think of how many sixes go into 6. That one I can do easy. My estimate's going to be 1. Okay, so now I start. D divide, how many sixes go into 6? I know that's 1. I multiply that. 1 times 6 is 6. Then I subtract. 6 minus 6 is 0. I check it. Is 0 less than 6? It is. Okay. Do I have anything to bring down? I do. I have a 7 to drop. Okay. Do I have a remainder? Well, no, because I have 2 empty place values at the top I need to fill. So that means I repeat the steps. I go back to the beginning. How many 6s go into 7? 6 goes into 7 one time. I multiply back. 1 times 6 is 6. I subtract. 7 minus 6 is 1. Check it. Is 1 less than 6? It is. Do I have anything left to bring down? I do. I have an 8 here. So I drop the 8. How many 6s go into 18? I know that's 3. I multiply back. 6 times 8 is, 6 times 3 is 18. 18 minus 18 is 0. I check it. It's less. Nothing left to bring down. Okay, so now I have the digits 1, 1, 3 at the top. I have to place my decimal point. And I know my estimate is close to 1. With decimals in the divisor, all I'm going to do is bring it up when I'm dividing by a whole number. So that means my answer to 6 and 78 hundredths divided by 6 is 1 and 13 hundredths, which was close to my estimate of 1. All right, 2 more problems to practice with you. Let's do some double digits. I haven't done that in a while. So I'm going to start with an estimate. 45, well, I know it doesn't go into 1. I know it doesn't go into 18. I'm going to think 45 and 284. Well, I'm going to make some estimates there because I can't do that one in my head. If I make 45 50, and if I make 184 150, I know it'll go in 3 times. So I'm going to say my answer is going to be close to 3. Okay? So let's go through the process. Does 45 go into 1? No. Does 45 go into 18? It does not. Does 45 go into 184? Yes, I need a guess though. Don't know that one off the top of my head. So what I usually say is look at the first digit. I have a 4 here. 4 doesn't go into 1, but 4 does go into 18 4 times. So I'm going to try on the side over here, 45 times 4. See what I get. See if it's close enough to 184. And I get 180. Well, that's super close. That's perfect. It didn't go over, and it's close enough to work. So I'm going to say 45 times 4 is 180. I subtract, I get a 4. I check. Is 4 less than 45? It is. Do I have anything left to bring down? I have a 5. Yes, I do. Oh, that's perfect. 45 into 45. That one's easy. 1. 1 times 45 is 45. I subtract and I get 0. I check it. 0 is less than 45. I have nothing left to bring down. So that means I'm done with the problem. I just need to place my decimal. And as I said in the last problem, when you're dividing by a whole number, you just bring the decimal point up. So 184 and 5/10 divided by 45 is 4 and 1/10. Now 4 is pretty close to my estimate of 3. So I'm pretty sure I'm correct. All right, one more problem, ladies and gentlemen. Now we're dividing 12 into 83 and 94 hundredths. before you do this problem, what I'd like you to do at the very bottom of your paper right now, write your favorite food in nice big letters, just putting in a secret code so you get extra dojo points for watching this whole video. So make sure it doesn't run into your division problems, but tell us your favorite food. All right, so here we go. 12 into 8. Oh, I'm sorry, we need to estimate first. What am I thinking? Well, if I make 12 10 and 83 80, I'm thinking it's going to go in about 8 times. So that's my guess. Okay. I think I'm going to use that as my guess here too. 12 times 8. Let's see if that's close to 83. 96. Well, that's a little too big. So I'm going to try times 7. 84. Oh, so close. Okay, one more time. Let's try 6 and get 72. That'll work. 12 times 6 is 72. I get 11. Check it. Is 11 less than 12? It is. So everything left to bring down? Yes, enough. So I'm dividing 112 into 119. I need a guess. I'm going to go big on this one, I think. Actually, I have times 8 is 96. I'm going to just try times 9 to make sure that isn't my answer. Oh, it actually is, because 12 times 9 is 108. We have 119. So I'm going to place my 9 there. Multiply back. 12 times 9 is 108. I subtract and I get 11. 11 is less than 12, and I do have something else to bring down. So I drop my 4. 12 into 114. Well, I already know 12 times 9 is 108. I'm just going to repeat that 9. That works well. Okay, so I end up with 6 left over. 6 is less than 12. I don't have anything else left to bring down. Here's the tricky thing about decimals. You're not allowed to have a remainder. You must extend the problem and keep it going until you end up with a 0 or a repeating decimal, which is something that you'll learn about later. So what I'm going to do is place a 0 at the end. I'm going to drop that 0 down to keep the problem going. 12 goes into 60 5 times. 5 times 12 is 60. I subtract and I get 0. Now I'm done. I just have to place the decimal. So I'm looking at the problem. I see the decimal point here. I bring it up. I get 6 and 995 thousandths, which is close to my estimate of 8. So that worked perfectly. Sorry about the barking dog. She's a naughty puppy sometimes. Have a great day, everybody. Keep up the good work.